Okay, so we're back. Welcome back to everybody. We're glad you're here. This, you kind of can view this engine from this side. And so I kind of wanted these letters to be letters that you can read from this side. But you can also view this engine from this side. And so I thought maybe those crankcase pressure balancing piston letters should be readable from over here too. And so what happens is you have the crankcase pressure balancing words here, and you have the same set of words here. They're just facing in different directions so that it's readable from either side. There's only one crankcase pressure balancing piston. There's not two of them. Okay, and over here we can see that we have divided the rotation of the crankshaft up into 10-degree increments. So there's 36 of them, 36 views. And we currently have the crankshaft at position of 360 degrees, and it's all very arbitrary. 360 degrees is the place where the little arrow that I connected to the crankshaft is pointing towards the number 360. There's no magic here. It's just because it gets extremely confusing. Remembering that this whole entire structure is running all the time and around in circles, and it's easy to get yourself mixed up. We should talk a little bit about what is the point of this engine. Why was it even thought of or constructed? And we wanted to make an engine that doesn't make any noise, because it makes no sense to try to create a robot that sounds like a chainsaw. It's not going to be acceptable. And that's easily done with electric robots and batteries and electric motors, but meaningful amounts of power that you can carry around with you. Remember, the robot needs to be autonomous, so it needs to completely be totally disconnected from anything. So it needs to have enough energy to do whatever it's doing walking along without having to go recharge its batteries. And my intuition at present with current battery technology and engine technology is a robot that has enough excess power to be able to be helpful is not going to work with battery power. This is just my opinion. This is why this engine was created. It's a silent engine. The thing that needs to be remembered about engines are basically air pumps. The more air you put through them, the more fuel you put into them, the more power they make. And in general, the expensive part of an engine are the parts. So a small engine running faster makes more power from the same amount of metal parts. So it's less expensive to generate power with engines by running them faster. The principle of science that is involved in running the engine faster is you've got to get the air into the engine, but you've also got to get the exhaust gases out of the engine. And the movement of the exhaust gases generates noise. The definition of noise is related to the difference in pressure between the pressure of the air, which is 1 atmosphere, and the pressure of whatever gases you're putting out into the air. The higher the pressure is of the gases entering the air, the more loud the noise will be. And in order to run an engine faster, it's essential that you take the exhaust gases and get them out of the engine. And the only way to get them out of the engine is to pressurize them so they will leave. And as you run the engine faster and faster, the exhaust gases have to be moved out of the engine faster and faster. And the only way to move them out faster is to put the exhaust gases under more pressure. And as you get an increased differential of pressure between the exhaust gases and the atmosphere, this increases the noise. And I wanted to make an engine that doesn't make any noise. And so you got to slow it way down. The RPMs have to be much, much, much slower. So the piston chambers get bigger and the RPMs go down. That's the point of this engine. It's backwards from any engine you've ever seen or thought about.